All right, so a little more of the same, what we've been doing. I'm just going to put a test, quote unquote, test for Thursday for those looking again to change a test grade, since we've only had a couple so far this semester, and the one in particular wasn't very good. So that's going to be Thursday. Just another round of these definitions and types of problems. We should hopefully be becoming pretty efficient at that, depending on how you did in that quiz. The test will have more questions. You're probably looking at 15 to 20 questions as opposed to a 10. But again, most of them are pretty short and very much in line with what we have been doing. Vocab will definitely be a part of that, so know all of these. We'll go through these again real quick. And then what I'm going to do is, I'll try to explain this in the Skyward video, but I'll do one of each. There's pretty much two every type. I'll do one. I'll leave you a few in terms of wanting to get some assignment points. Just show me that you're doing some stuff here. Then just take a picture of whatever's not done. Submit it to me later, okay? So as we go through, this is read as line. Since there's two arrows there, AE is A. If we find AE, okay, looking through here, AE is touching the circle on one point. So this is what we would call a tangent line. This is read as a segment, CD. Notice how the one above it had arrows. That's why it's a line. CD does not have arrows. That means it is a segment. So if we find from C to D, so just from here to here, that's our radius for the circle, from the center out to the circle. The curved line on top is an arc. Anytime we have three, that's either meaning it's probably going to be a semicircle or a major arc. So if we kind of follow where A, B, and D are at, get rid of these now. So here's A, we're going to B, we're going to D. When we go around this, what we would find is that's halfway around the circle. So that's our semicircle. Segment AF. So if we find A to F, and then it's a line segment, then that would be from here to here. So from one point on the circle to another point on the circle. That's what we call our chord. Number 5, line FB. So find F and B, but it continues on through because it's now the line instead of a segment. This is what we call a secant. Angle BCD. Let me clear these before it gets too messy. Here's B, here is C, here is D. So we're going from here and then to here. So this angle is a central angle. It's in the center of our circle. That's where that angle is formed, with the center as part of our circle. Segment AD. So A to D goes right through the middle. It's a chord, technically, but it's the chord that goes through the center of the circle. Allows us then to give that a more specific name. That's the diameter of our circle. Angle AFB. So here's angle A drawn to F, and then F is drawn to B. Notice how that angle is formed by a point that's on the circle. Those are called inscribed angles. It's the point, or the vertex is actually on the circle. C is the center of your circle. C is the name of our circle. Arc DF. So if we find DF right here, it's an arc. Since it's less than half of our circle, this is what we would call our minor arc. 11A, if we find A is a point, and in this case of tangency, since that's where the tangent line touches our circle. And then lastly, arc BDA. We talked earlier, if you have three, I'm going to do this one in yellow. If we have 3 letters naming an arc, that's either going to be your diameter or a major arc. So if I go from B to D, so we're going in this direction, and then continue on around to A, we've gone much further than half away. So that's not our diameter, that is a major arc. So those are our definitions. You'll definitely get a handful of those. Should be easy points. Have this sitting next to you. have your notes sitting next to you so you can just reference them. And especially if you're needing to do well in this test to raise a grade, you have this available to you. All right, so now I'm going to do one of these. I'll leave you the other. Actually, yeah, I'm going to do these two, and then I'll leave you 15, 16, because those are similar. 13 is a central angle. If you recall, a central angle has the same, so this angle here has the same degree measure as the arc. So since this eats up 92 degrees, that means the angle is also a 92 degree angle. Versus an inscribed angle, so this is an angle that's inscribed, it's on the circle, not at the center. This is always half of this angle. So if this is 74, if we just did 74 multiplied by 2, then this would have to be twice as big. So that would be 148 degrees. All right. All right, 15, 16, I will leave you those. So if you want to get some points, really cheap free points, you'll finish 15, 16. I want to see that those are done. 17 and 18, I'll do one, leave you the other. Same with 19 and 20. And then, you know, take your 10 minutes to do those, send them to me, we'll be all set. So 17, you're given that from D, let me do this in yellow so we know what this is. So from D to C, that's a 144 degree angle, or 144 degree arc. Then you were told that the central angle here is 102. And then you're asked a series of questions. So let's jump to one of the things we know for sure before we even really look at this, is the arc, do this one in red, from here to here. Since our central angle is 102 degrees, this arc has to be 102 degrees. If you notice then from D to B, what color? I'm going to pick this color. This is the arc that we are still missing. Well, if we did the yellow, red, and purple all together, we know that has to add up to be 360 degrees. And we already have 144 and 102. So give me a minute while I plug this in. 360 minus 144 minus 102. This would have to be 114 degrees. All right. Let's see if the question's an ask. We will probably have knocked out most of this with that. So the measure of arc BC, we've already shown. That's our red arc. We know that was 102 degrees. Let's jump down to this one. The next one, the measure of arc BD, that's our purple one. That had to be 114 degrees, we found. Find angle DBC. So this we do in black. So here is D to B. And then from B, we want to go out to C. So what we have here is a central angle. We are looking for this angle right here. And what we know is the yellow arc is the arc created by that angle. And 144 would be twice as big as this angle. So do 144, cut that in half, and then we know that angle has to be, or that degree has to be that angle, and that is what, 72 degrees. Okay. All right, 18, I will leave you. Should be able to get through that. Okay, correction, 19 should go with 17, so 19 and 17 are similar. So I'll do 18, and then we'll leave you 20. So number 18, let's get some things out of the way real quick. We know that from here to here, if you look at this central angle being 118, that means this arc here has to be 118. All right, so we know that. Other thing we know then is this is a diameter here. More importantly, it's a straight line. So if you remember, in a straight line, there's always 180 degrees. So if we know some of that is 112, if I just did 180 minus the 112, that would then tell us that this angle here, if I can write this neatly, must be 68 degrees. All right, so hopefully that makes some sense. I'm going to erase some of this so it doesn't get too congested in here. We now know that angle is 68. What that then would tell us is, let's do this arc here. This arc, central angle, would also have to be 68 degrees. All right, so now let's look at our questions. Number 18, arc LM is what we just wrote down. The red arc has to be 68 degrees. the measure of angle KLM. So where are we at here? So K to L to M. So this one we do have to do a little bit of calculating yet. We haven't done enough for this. What that creates is, let me do this in purple. That angle creates this, whatever color you call that, kind of bluish green arc. That's an inscribed angle. Those are always half of the arc that they are creating. So the first thing we really have to figure out is, what is that degree measure? If you look, we now have, if you combine the yellow, red, and the kind of weird color all together, that makes up the full 360 degrees of our circle. So if we did 360 minus the 118 minus the 68, we would find, let me do this in a different color, that this multicolored one is 174 degrees. And this angle here then has to be half of 174. All right, so divide that by 2. And we should get angle KLM to be 87 degrees. Next one, trying to create some things here. This one is to find KML. So now I'm going to go from K to M, and then from M to L. So if you look at that angle is what creates the yellow arc. All right, starting here, going to here, that's where the yellow arc is. So KML has to be half of 118. And that should be 59 degrees. So 17, 18, you can look at those two to model 19 and 20. 21, let's see. Okay, yeah, a little trickier one. Let's fill in what we know. That's 27, so we know this arc here is 27. If you also notice from, this is C, got kind of cut off a little bit, B, and then that's D over here. Let me just mark it over here. D to B is the diameter. The diameter cuts our circle in half, so that means that creates 180 degrees on both sides of it. So if we did 180 minus that 27 degree arc, what that would tell us is this would have to be 153 degrees. And then the same thing on this side. This has to be 180 degrees overall because we're cutting that in half. So cutting the circle in half. So 180 minus the 138. And then we would know this would have to be 42 degrees, even though it looks odd. All right, we'll go with it. So with all that, then let's go through, identify what we need. Angle C, let's do these first, the arcs, because these we should have. Measure of arc DA. So DA is 153. Have that written down. The measure of arc DCA. So we got to add these. So let me do this in all yellow now. D to C, all the way around to A. We're adding all three of those. So we have to add up 42 plus 138 plus 27. And that should give us 207 degrees. Then our angles. So now, we'll go with it. Angle CDB. So angle CDB is this angle right here, created by these two. So that's forming this arc right here, which is 138. It's an inscribed angle. It has to be half of 138. So divide that by 2. Should get 69 degrees. And then DBC, find that angle, is this angle here. So look from here to here. I get too sloppy. And then that forms this arc right in here. And that's 42 degrees. So this angle has to be half of 42 degrees. So that angle must be 21 degrees. All right. And then last but not least, real quick, there's a couple of these, should be pretty basic. This is an interior angle. And then what we talked about when we do that is if I want to know what these degree measures are, if I know DI is 90 degrees and I know measure of arc DE is 30 degrees, angle 1 is 1/2 of those guys added together. So if we did 30 plus 90, angle 1 has to be half of 120, so that would have to be a 60-degree angle. That's for interior angles. All right, this is an exterior angle. So if I would know measure of angle T would have to be 1/2. And in this case now, WR is 120. AE is, let's add this. Let's make measure of arc AE 40 degrees. So then this is 40 degrees. Angle T is 1/2, just like this one, half. This one also is half, but instead of adding these angles together, we are subtracting those angles. So the measure of arc T would have to be half of 80, so that would be 40 degrees. That's all I got. We don't need to keep on hammering our head against the wall with this. This will largely wrap up, testing or whatever. We'll do a little reviewing and then just a little bit of a bigger test at the end of, a couple of weeks for, again, those looking to get some engagement in here or just trying to raise your grade with another test score, since we haven't had a whole lot of those this semester. If you have any questions, let me know. Take a picture of the ones we have not done, send them to me with all of it, and should be good to go. Have a good day.